Hi, I'm Timothy Spann, Developer Advocate at StreamNative. Today I'm going to talk to you about FLiP into Apache Pulsar apps with Scylla. I've been working on what I call the FLiP stack or variant of that for a little while. That is a combination of Flink, Pulsar, Scylla, NiFi, Spark, some things in modern data development that work really well together. In the past, I was a principal engineer at Cloudera, senior engineer at Hortonworks, field engineer at Pivotal, always working with data, streaming, messaging, things like that. Today, everything's in the cloud, so we're going to be talking about cloud streaming, and something that enables that really well. It's an open source project, Apache Pulsar. This gives us a number of features that work really well when you need to do real-time messaging, things that are very scalable. It includes some features that make this really powerful and pretty straightforward. There's a built-in serverless computing framework, and today in my demo I'm using that to run sentiment analysis as data enters topics and goes into our output before it gets landed in Scylla. And what's nice is we've got unbounded storage. That's important because in cloud use cases, you're really hard to decide how big these applications are going to be, how much data you get, especially when you start bringing in things like, live data, logs, sensor data. Lots of data out there fills the storage up pretty quickly. We're multi-tiered, so we could scale things independently, wherever that needs to run. Our storage layer is isolated from the computing layer for our messaging, and that lets us scale things out. And as well as storing things in these individual nodes, we've got a tiered storage system, so we could store it out to AWS, Google Cloud, whatever cloud storage you have out there. To support all the different messaging types, we support streaming like you used to with Kinesis, and pub sub that you might be doing now with things like RabbitMQ or ActiveMQ. You could pick and choose how you want to interact with the messaging system. And we've got support for other protocols out there depending on what you're using already, so you don't have to rewrite everything to move over to Apache Pulsar. Now, if that wasn't enough, there's some features underneath there that are really important for modern data applications, especially once you're talking cloud, hybrid cloud, you're in different regions. Having this unified messaging platform so you don't have to have 12 different ways to do your messaging. We could support JMS, we support Kafka, support MQTT, whether you need to do it streaming style exactly once, or you have, using your messaging system as a work queue, all that's supported. We guarantee that all your messages get delivered, they never get lost, and they can be stored forever. So you don't have to worry about it. Very resilient architecture with those multi-tiers, keep things isolated, keep things alive, very easy to scale up and down automatically with things like Kubernetes, and as large as you need to make these clusters wherever it needs to run. Geo-replication's built in, so if I need to run tens of thousands of nodes spread around the world, not a problem. There's large Pulsar users in Asia now. It's scaled up to tens of petabytes without a problem, thousands of nodes. So your scale is as big as you need to be. There's a lot of use cases where that applies, pretty commonly. And these are use cases often connect with Scylla. Having that unified messaging platform is nice, so you don't have to worry about, I have JMS over here and RabbitMQ over here and MQTT over here and Kafka over here and Kinesis over here, and I've got to use different libraries and they can't talk to each other, or I've got legacy apps that are talking this way or another. Having one system that handles them all, scales out, modern data infrastructure, runs on all the clouds, runs in Kubernetes, all those cloud native features you need. Ad tech, huge one where you need low latency. You've got a lot of data coming in very quickly. You need to have different clients access it. Ad tech is an easy one for us. Fraud detection, while data's coming in, I need to make decisions on it right away. I need to look at some data that I have stored, combine that with data that's happening now. Very good one. Connective car, when you've got a ton of data feeds and you may need decisions made right away. Maybe those decisions need to be made at the edge. That's something we do with IoT analytics, because I can have my Pulsar clusters run small. I can have an edge one that's running in a small edge gateway, have that geo-replicate automatically to my larger clusters that are hosted in various cloud regions, and not have to really do any complex setup or management to make that work and work scalably and solid. Very easy. And to support things like microservices, very easy. We're using that today in the demo. This is my architecture that I commonly use in a FLiP app, and this is the one I'm using today in my demo. I've got some sources of data. I've got a interactive single page web application that is letting me type in questions, or is how many people are using the app, type in questions and send them via WebSockets to Pulsar. Pulsar supports WebSockets natively, so it's very easy for you to make communications there without custom libraries. Or I could have communicated via Kafka or MQTT or REST or the Pulsar native application. Lots of options there. Also have a edge device pushing in sensor data. Again, could also run in the near term CDC type application. So if I need to get data in and out of Scylla that way, I could do that. Data comes in, and like I said, for the FLiP part, Pulsar is usually backed up by Flink, because Flink gives us some extra horsepower for computing to do things like continuous queries, continuous ETL, and whether it's batch or stream, same paradigm, very easy to combine these together, and Pulsar can automatically offload that data to that cheap, massively storable, massive sized S3 and other cloud storage. And then today, very easy for me with just a couple lines of configuration to stream that data via Pulsar Sync, which is a built-in connector you can enable and go right into a Scylla table. And I could also do things like run Spark against anything that's while it's still on a topic, or run, I'll show you little pulsars running against it with Pulsar SQL so that you can look at the data in your topics right away. But let's connect here. Lots of different options. So it's not just sitting in this message queue, it's live data. And as soon as an event or a message or a log or a record, regardless of where it comes from, regardless of that protocol at the beginning, once it's in, I'm in a topic, I can have it execute lightweight code. This is that stateless compute layer that I talked about, and that supports Java, Python, and Go. I've got a Python app that's doing NLP on it to analyze the text as it comes in. Great way to do functionality that's a microservice and not too hard to deploy, that gets deployed to a cluster or to Kubernetes on its own, and then gets each message as it happens. Very nice. Then we have connectors. We're using that today. We're using the connector to act as a sync. I put in a little connectivity and it goes right to there as it enters that topic. Very easy for you to get that data into something like Scylla right away. We mentioned those different protocol handlers. So if I need to get data in and out of Kafka, I'll just look like I was Kafka. No extra headache there. Once the data is in Pulsar, it supports any way in and out. I could use Kafka in, MQTT out. Makes no difference to Pulsar. We got those processing engines I mentioned. Pulsar SQL, which is our, look at a topic, see what data is there right now. That's done with Presto Trino. Pretty easy to do that. Simple select star or select whatever fields you want. And we mentioned those data offloaders, so I could just tier out that data when I get to a certain size or time, age that data out, but still have that available for things like Pulsar SQL or Flink or Spark, or just ready consumers. Just because it's not in the immediate storage of Apache Bookkeeper doesn't mean it's not available. So as I mentioned, we have that sync there. It's very easy to set up. So we could build and run an example very easily. This is all I need to connect to Scylla. Obviously, if I have different configuration needed for login, password, different login mechanisms, but this is the basics. I'm running Scylla in a single Docker, just as a easy to use demo that I'll give you the source code from. Put in my connection. It's going to look pretty familiar to you with that familiar port of 9042. Got a key space and a column there. You know, I could do it depending on what my schema is, but I keep it pretty simple for these examples. I created a key space just for this demo. And then from Scylla, this is what I could do from the command line. Or I could do this from the UI. Pretty easy to do it from the command line and then connect it with my DevOps tool. I'm going to create this in a different tenant and namespace. You know, with the short talks, I didn't mention that. One of the nice features of Pulsar is it supports multi-tenancy, and it does this by letting you create tenants and underneath them namespaces, so you can keep all your applications, different developers, different things together. So I've got a tenant, a namespace, and then my topic, so it keeps things separate. Lets you scale up to millions of topics and not have to worry about creating these massive weird name things. For this, it's just chat result 2, and you'll see how we get data into there. So this is all I have to do. I point to that config file, give it a name, give it a sync type, press return. In a few seconds, it's built and deployed that. You'll see that in the logs while it's running. Now, I mentioned these functions. So it'd be good enough that, you know, you throw data into a topic, it's automatically in that Scylla table. That's great. But I wanted to do a little work on it. So I have a function here that does sentiment analysis as that chat data is coming in real time, drops it into chat result 2, then drops it into Scylla. Pretty straightforward. I've got a single page web app. Very simple. I built this so I can do things like at a conference or at a meetup, give everyone access to the URL, and everyone can ask questions. Right now, the only thing it does is there's that function that does the sentiment analysis, but these functions are chainable, so I can add one that maybe tries to answer the question using something like BERT Q&A, or maybe does a lookup at the documentation, or maybe post a Slack out there and someone can interactively push something back from our engineering community, or, you know, do some other NLP to break it up and, you know, maybe supply some best case lookups, or maybe results of a web search, you know, point to different news feeds, search Twitter. You get the idea. Pretty easy to do. Again, nothing in the app is Pulsar specific. This app just talks to WebSockets and gets data back from a different WebSocket. You know, that just happens to be native Pulsar, and Pulsar uses those calls to push data into a topic and pull something out of another topic. Gives you a very easy way to have live data happening on a web page that doesn't have any back end. Pretty straightforward. Now, I'll show you a little bit in live demo since we have a couple of minutes here, but I wanted to tell you something we're looking at in the community in the future. We want to make that connector faster. Now, it's pretty fast now, but we want to take advantage of some of the performance enhancements that Scylla has. So we're working on a shard-aware Pulsar connector. If you're interested in this, if you've got some cycles you want to help out with documentation, testing, engineering, definitely reach out. I hope more people are interested in this more advanced connector. But for now, that's future work. If you're interested and you like what you're going to see in the demo in Pulsar, we've got free training online. We've got a nice webinar that shows you 3 different ways that we build microservices and then add some Flink SQL at the end. That's pre-recorded, easy to do. If you're especially interested in that connector, definitely join our Slack. It's a pretty active developer community, and we're always eager to help new people or help people who maybe want to get involved in working on things like that connector. Thank you, but before we go, we have time to look at the demo. So let's pop into that. This is that single page application, and it's using some simple libraries here. I am not a front-end developer, so maybe this isn't the prettiest thing you've ever seen, but what's cool is it works. So I like that. And it's got some nice features in this data table library. So it could do things like search, find some of the latest messages, do a sort, maybe ask another question of, is Scylla awesome? I don't think I need to ask that. You know the answer to that. And then we get the result for that. And we have different things here. So if we had a bunch of different people doing this and everyone was asking questions, we get them back live, pretty straightforward. Underneath the covers, that's talking to our topics. And as you see here, we've got full ability to see everything going on. What's going on beneath the covers is pretty advanced. It's breaking up data into segments, so it's stored in different layers. It's keeping track of different people who are consuming this data here. You can see there's our Scylla sync that is grabbing this data really fast as it's coming in, sending it through. And I've got a couple of different other consumers out there reading this data. I don't have any policies on here, but we can make different people able to see different parts of it. I could break up this topic into partitions. Lots of different things we could do here. I could add new subscriptions to see what's going on. If there's a schema with the data, I can see that schema, and there's a built-in schema registry. Makes that pretty straightforward for different things we're doing. And if you're interested in seeing that, pretty cool. See here, we could see our data came back from a topic. So what happens is I sent it over WebSockets, went into a regular Pulsar topic, activated that microservice. It ran some sentiment analysis, pushed it into another topic, and this guy is subscribed to that topic, getting new messages as they come in. And I could sort by the time that it got published. Pretty straightforward. And at that same time, that same result got pushed into Scylla. I hate to show command line, but I want to show you that that data's there as it's coming through. It's very nice being able to talk to you about these combinations. If you're interested in some of the stuff under the covers, we could dive a little deeper. Like I said, with that multi-tenancy, I could support multiple tenants in one cluster. So I set one up for meetups. I have a public one that's there by default where everyone could put common stuff. And there's some internal ones that are used. Like in my meetup, I just have one namespace for my New Jersey meetup that I'm doing pretty soon. And then just the topics that are there. I only have one topic. And I've got 2 subscribers here, and you can see what type they are. We mentioned different subscriptions. They can be things like exclusive, which means only I get them. It can be shared, where multiple people can have them. It depends on how you want to get the data. Do you need it exactly once? You want it just fast? You need it to work like a work queue. You pick your different subscription types and go from there. Pretty straightforward there. Not the most difficult thing in the world. What else can we show you real quick? That's pretty much it. What's kind of cool here is this is a way to consume your data from a live message queue from a single page application where there's no mention of Pulsar. If you look through the source code, which I'll give you the source code link when we're at the end of this along with the slides, you can see it's just a standard WebSocket call from jQuery. You make that call, you get back data as JSON, parse it out, and you're ready to go. Easy to apply that to something like a live data table or something else. So I'm Timothy Spann, and thanks for coming to my talk. Hopefully you enjoyed it and enjoy the rest of your conference. Thank you.